welcome to problem set number 3. Our topic is chemical versus physical change and classifying matter. Before we get started, I do want to remind you that I do make the worksheets available online through my website, and I do recommend that you have those in front of you as you're going through these problem set videos. All right, with that said, let's get started. Number 1, classify the following as either a pure substance or a mixture. A is helium gas. Okay. I'm just going to write the symbol there. So if you look at your periodic table, you will see that helium is listed there. That means that it is an element, which makes it a pure substance. Okay, B, carbon monoxide gas. Just going to again write the symbol. Okay, so we see two elements, carbon and oxygen, combined in a fixed 1-to-1 ratio. That makes this a compound, which is a type of pure substance. Okay, and C, 14-karat gold. Well, gold itself is an element, but 24-karat gold is pure gold. 14-karat gold means it's only about 60% gold, and so that is definitely a mixture. It's mixed with some other elements. So right, for 14-karat gold, that's a mixture. And last but not least, 1% milk. Milk has fats, proteins, water, lots of different things in it. We know it has a variable composition because we can buy skim milk or 1% milk or 2% milk or whole milk. So milk is definitely a good example of another mixture. Okay, number 2 refers us back to problem number 1. So I'm going to write that just over to the side here. For each problem in number 1, classify it further as an element, compound, homogeneous, or heterogeneous mixture. So A, helium, we already said that that's listed in the periodic table. That is one of the 115 known elements. Oops, I should write A there. Sorry about that. Okay. B, on the other hand, has two elements in a fixed 1-to-1 ratio. So B, carbon monoxide, must be a compound. C, 14-karat gold, it's definitely a mixture. It should be a homogeneous mixture because you want that gold and all those other elements that make up the 14-karat gold to be evenly distributed in your precious fine jewelry. So that is an alloy of different metals. That is a homogeneous or homogeneous mixture. Okay, D, 1% milk, definitely homogenized, right? Homogenized milk, that is a homogeneous mixture. Meaning it should be uniform throughout. Your first drink of milk should be the same as your last. All right, let's go on to number 3. Classify the following as either a chemical or a physical change. A, water freezing. Remember that all phase changes are just physical changes. Water freezing, going from the liquid to the solid state, is still just H2O. It has not changed the chemical composition of the substance. That is a good example of a physical change. Okay. B, glass shattering. It's still glass, even if it's shattered into multiple pieces. You've not changed the composition of the glass itself. Okay, so that too is a good example of a physical change. Okay. C, making orange juice from frozen concentrate. That would be a good example of dissolving. You dissolve it into water. Remember that that is just a physical change. D, burning a candle. Definitely chemical. When something burns, that is always a chemical change, combining with oxygen, some fuel combining with oxygen. It's a chemical change. Okay. E, hydrogen peroxide decomposes into water and oxygen when rubbed on the skin. So think about when you put hydrogen peroxide on a cut or a scrape, you see it kind of bubbling. It's decomposing into water and oxygen gas. Okay, so that would definitely be a chemical change because the identity of the substance is changing into new, different substances. It's changing into water and oxygen gas. And then finally, F, water boiling. That is just a physical change. That's just a phase change. Remember, we put boiling under phase changes in tutorial number 3. So physical change. Just because it goes into the vapor phase and is now water in the gaseous phase doesn't change the composition, which is H2O. Okay, so it's still water. All right, number 4. Indicate the state of each substance at room temperature, which is roughly around 22 degrees Celsius, and atmospheric pressure, about 1 atm. Okay, so the conditions that we're used to on a daily basis inside of a room. A, table salt, okay, sodium chloride. So think about the state that sodium chloride is in. It is definitely a solid, it's a crystalline solid. B, oxygen, it's in the air, it's a gas. C, water, at room temperature, atmospheric pressure, always a liquid. And D, sugar, table sugar, sucrose, is also a solid, a white crystalline solid. All right, let's erase here before we go on to number 5 so we have a little more room. Okay, number 5. Butane has a melting point, I'm going to write some of this up here on the board, of negative 138 degrees Celsius and a boiling point near 0 degrees Celsius. What is the state of butane at the following temperatures? Assume normal atmospheric pressure. Okay, so you don't have to worry about pressure. So what I like to do here is make a little diagram for myself. Okay, so we know that butane would be a solid below negative 138 degrees Celsius. Above that, it's going to be a liquid. It will have melted because that's the melting point. Okay? And then at 0 degrees Celsius, that liquid butane would boil off into a gas because that's the boiling point of butane. So this little diagram might help me to answer A, B, and C for number 5. Okay, so A, at 23 degrees Celsius, which would be above, we label that as BP and NP, melting point and boiling point. 23 degrees Celsius would be above the boiling point of butane. So at 23 degrees Celsius, we would expect butane to be a gas. Okay, so roughly room temperature, somewhere around room temperature, 23 degrees Celsius. B, negative 8 degrees Celsius would fall here, where butane, put a little arrow there, would be in the liquid state. Okay, it's below the boiling point, but above its melting point, so it would be in the liquid state. And C, 0 Kelvin, a little tricky here, going back to tutorial number 1. 0 Kelvin is equal to negative 273 degrees Celsius, because remember, to find the corresponding temperature in degrees Celsius, you have to subtract out the 273. Okay, so negative 273. So that would fall below the melting point, or 0 Kelvin, right, 0 K here. Okay. which means that at that temperature, 0 Kelvin, butane would be a solid. Okay, be below its melting point, so it would be in the solid state. All right, number 6, and that's it. Number 6 is a long one. When sodium metal is dropped into water, there are 2 products formed. One is a gas and the other is a water-soluble substance. The gas cannot be broken down further by chemical means. The water-soluble substance can be broken down further into the elements sodium, oxygen, and hydrogen. Classify the 2 products, that would be the gas and the soluble substance, as elements and or compounds. Okay, so I'm going to write out sort of not a real chemical equation, but a pseudo-chemical equation. So sodium metal dropped into water, and 2 products form. One is a gas, and one is that water-soluble, running out of room here, substance. Okay, it doesn't tell us exactly what they are, so we can't write these 2 products out in their chemical formulas or even write out their names, but getting an idea here of the reaction. Okay. All right, so they say the gas cannot be broken down further by chemical means. So it's in its simplest state. So the gas must be an element, the basic building blocks for all matter. That's why it cannot be broken down further. The water-soluble substance, on the other hand, it says can be broken down into sodium, oxygen, and hydrogen. Okay? So the water-soluble substance can't be an element because it's composed of 2 or more elements combined. So it must be a compound. Okay. All right. So that concludes problem set number 3. I hope you will consider tuning in to tutorial number 4, moving forward with your chemistry studies. Thank you.